Okay, so this problem says it is difficult to extinguish a fire on a crude oil tanker because each liter of crude oil releases 2.8 times 10 to the power 7 uh, joules of energy when burned. Okay, so you burn a liter of oil. A liter of oil is that much, that drink bottle. That's a liter of oil. You burn that much oil and you get 28 million joules of energy. To illustrate this difficulty, calculate the number of liters of water that must be expended to absorb the energy released by burning 1 liter of crude oil. If the water's temperature rises from 20 degrees to 100 degrees Celsius, it boils and the resulting steam's temperature rises to 300 degrees Celsius at constant pressure. Discuss the additional complications caused by the fact that the crude oil is less dense than water. Okay, so what we're going to do is we're going to burn 1 liter of oil. There's heat released, 28 million joules. And what we're going to do is dump water on it. The water is going to absorb all the heat. If the water absorbs all the heat, then that heat is not available to go burn more oil. That's how you put out fire. Okay? So the heat is the culprit. You don't want the heat to cause other problems. You absorb it in water. Okay? So how much water is needed is the question. All right, so how much heat do you have at your disposal? 28 million joules. Okay, so we're going to give it to the water. So what we are going to do, mass of water times specific heat of water, and we're going to warm the water from 20 degrees to 100 degrees. Then what we're going to do, what are we going to do with this thing? We are going to boil this water away. Okay, so the mass of water times the latent heat of vaporization. Then we are going to take that much water, which has become steam, and heat it to 300 degrees Celsius. So that's what we're going to do with this heat. Okay, so let's find what is that mass of water. So the mass of water would be Q divided by CW times 80 degrees Celsius plus mass of water, latent heat of vaporization plus specific heat of steam times 200 degrees Celsius. Okay, that's the mass of water we need to dump. Okay. All right, so let's do the numbers here now. Okay, how much heat do we have to dispose of? 28 million joules. The specific heat of water is 4186 joules per kg, 80 degrees Celsius. What is the latent heat of vaporization of water?
2,256.
Specific heat of steam?
Is 1,520.
What?
1,520.
Latent heat of vaporization is 2256? No, that doesn't sound right.
You don't get much from the reagents. It's kilojoules.
Yeah.
2 kilojoules.
2256 kilojoules.
Kilojoules.
Yeah.
Not just joules. Is that better?
Nine point 7 kg, and so density mass is volume is mass of water divided by density of water, which is 9.7 kg, and density of water is 1 kg per liter. So 9.7 liters of water. All right, so you have 1 liter of oil burning. Oil floats on water, it's a thin layer, and then you're going to dump 10 times as much water to absorb all the heat. And of course, you dump water and the water spreads in a thin layer. Of course, we have a very thin layer of water on top of it. So you're never ever going to put out the oil flame using water. So what do? How do you put out that flame? So, yep, you have to somehow figure out a way to cut out the oxygen. So that's the common theme. If you can't remove the heat for it to cause more burns, you have to somehow cut off oxygen. Put a thick layer of foam or something, some kind of chemical foam. Okay, and that's how you cut off the oxygen.